Welcome out, guys. I think we're going to get started. We're a few minutes early, but it seems like most people are ready. So welcome to Frontend Craftsmen. Just as a reminder, we're part of the Forge Utah organization, right? So we're a coalition of meetups here, mostly sponsored by Weave. So tonight we're doing Frontend Craftsmen. We've also got Kubernetes, Golang, and the Machine Learning Utah meetup. So most of those are here Tuesday evenings. Come check us out. You can find us on Slack, bit.ly/Slack to get joined up. We'll post slides, recordings, info for new meetups, interesting discussions, that kind of stuff. Tonight we've got Matt Lawton from Pluralsight. He's going to be presenting on enterprise applications, which should be awesome. Coming up next month, we're going to have Nate Singleton, who's an engineer here at Weave. He's going to be presenting on HTML and CSS, but beyond the basics, so you can level up there. Hope to see you out again. Make sure you grab stickers before you go if you want them, and there's a ton of pizza, so please dive in. Thanks, guys.
Hey everybody, I'm Matt Lawton. Today I'm going to be talking about building enterprise scale applications. So a little bit about me. I'm currently a software engineer and technical lead of the product team at Pluralsight. And over the last few years, I've worked on multiple enterprise single-page applications in React Redux, Angular, and AngularJS. So what are we going to be talking about today? We're going to be talking about some patterns and strategies for developing enterprise-grade single-page applications. What we're trying to achieve is enabling excellent user experiences and allowing multiple developers to work in a code base without stepping on each other's toes. Some of these things I've found it's often hard to find good documentation on. And a lot of these things are lessons I've learned the hard way actually trying to build these systems. So preparing for this talk, I started to make a list of everything I felt was important for enterprise quality client applications, and the list quickly grew to be longer than I'd have time to talk about today. So I ended up choosing the top 5 things I thought were most important and that I don't hear talked about a lot. So we're going to be talking about building a foundation of quality, improving loading times, analytics, tracing, and internationalization. So building a foundation of quality, what does that mean? It means everything you build must have impeccable quality. So to achieve that, you must have testing around all aspects of your application. And you must create a culture where tests are non-negotiable. Tests are the foundation of everything you build. And if you don't have a solid foundation, your app can't stay on top of it. Tests help you detect regressions, detect bugs, and act as a specification for your software for new developers coming in. So that means if you're writing React Redux, components, action creators, reducers, sagas, selectors should all be tested. If you're in the Angular world, components, services, directives, all that good stuff should be tested. It also means creating coding standards. So what are coding standards? Coding standards are patterns for all developers to follow when working in your code base. It should describe things like how to name files, how to name components, where to put files, where to put functionality, that kind of stuff. Where to put business logic. So for example, on my team at Pluralsight, we decided we're always going to put business logic in sagas inside Redux. That way there's a standard way for everybody to know where to look to see where the functionality is happening. It gives us standardization across the entire code base. And more importantly, where not to put business logic. So you should be describing things like how presentation components take in data and present views only. They shouldn't be making decisions themselves. They shouldn't be relying on global state, that kind of stuff. So what do coding standards get you? Well, it reduces the cognitive overhead and accelerates decision making, and allows developers to focus on adding business value. It also avoids nitpicking over things that don't matter. I'm sure you've all seen pull requests where people are arguing over personal preferences and small style issues. Coding standards mechanizes all these aspects and keeps developers focused on adding value that matters. Just a tip, you should probably all be using Prettier. Prettier is a JavaScript and TypeScript code formatter. You can set it up so when you commit, it automatically formats all your code. Gives you a nice standard coding style across your entire application without having to think about it. Even if you don't necessarily agree with all the choices Prettier makes, having a standard way of coding across your entire application is worth the value. So here's some example of coding standards we created on my team at Pluralsight. Notice we're describing things on how to name files, where to put things, where business logic should live, where business logic should not live, all those good things. So I'm sure some of you are thinking, well, that sounds like a lot of overhead. I just want to code. Why should I care? A few reasons. Number one, it conveys excellence. We call ourselves software engineers. If we want to be treated like professionals, we need to act like professionals. In any other engineering discipline, 90% of their output is diagrams and documentation. There's no reason why we should be any different. It reduces the total cost of ownership of the application. The initial build time and cost is only a small fraction of the life of the software. We should be building software that lasts many years. You're going to have multiple developers coming in and out of the project over the lifetime of the application, and they should be able to quickly understand the architecture and patterns of your app so they can quickly start adding value. And most importantly, it's the only way to ship functioning software. So what do I mean by that? If you have n components in your application, where each component in this case is a view component, a service, anything that has to interact with another part of the application, each component has a quality associated with it, where the value is between 0 and 1. So for example, if you have a component quality of 0.9, it means the component works perfectly 90% of the time, or 90% of the inputs work perfectly. If you have n components, each contributing 1 unit of value to your application, your total application value is the product of all your components and their qualities. So if you have 10 components that are all 100% quality, you have 10 application value, which is perfect and what we're aiming for. But if you have 10 components that are all at 99% quality, your overall application value drops to 9 out of 10. 10 components at 95% quality drops your application value to 6 out of 10. And 10 components at a quality of 90% drops your application value all the way down to 3.5 out of 10. So if you notice, this is a nonlinear degradation of the quality of your application. A 4% drop in quality degrades the outcome by 33%, and a 9% drop in quality degrades the outcome by 61%. Something that's very interesting is the more complex the application gets, the worse the effect. The degradation curve, the slope increases quite significantly the more services and components you add to your application. This is also why messy solutions seem to work initially, because the cost of the degradation is not very high when you have a small number of services. But as your application grows in complexity, the effect gets worse and worse. And as building enterprise applications, we're building complex applications. And so our entire product has to have a foundation of impeccable quality. Each component has to be rock solid to have any chance of success at delivering a functioning software. I had a client one time who had a really old legacy WinForms application, or WebForms, excuse me, application with lots of complexity and quality issues. They decided, well, we want to upgrade and modernize this application, so we should create a SPA for it. So they began building a brand new front end in AngularJS without addressing any of the actual fundamental back-end issues. So they released a new single-page application, and it had all the exact same issues as the legacy software because they didn't actually address any of the fundamental quality issues, but now they have 2 applications to support. So customers didn't want to upgrade because the new software didn't add any value to them. So they actually try to add new features to the clients to improve and get customers onto the new system. But all they did is make the system even more complex. They kept adding complexity under complexity without addressing the underlying quality. So to this day, they are still selling both the legacy and new version of their application, and they can't get customers to upgrade. And they started this project 4 years ago, I believe.
I can attest to that.
All right, so let's switch a little bit and talk to improving loading times. So many large companies have done studies on page load times. Amazon found that for every 100 milliseconds of latency they introduced, it cost them 1% in sales. And Google found an extra half second in search page generation time dropped traffic by 20%. So just adding a little bit of latency to your page can have profound effects. And the conclusion that all of them came to is that users hate waiting for pages to load. This is some data published by Google a couple of years ago on how often a user will bounce based on how long a client web page takes to load on a mobile device. Notice how fast it increases the longer it takes to load. So Houston International Airport had a big problem a few years ago. They got complaint after complaint after complaint that people were waiting way too long at the baggage claims. People were super frustrated for how long they had to wait for their baggage to arrive. The airport tried all kinds of things. They tried to hire more staff, hire better staff, have more efficient baggage unloading processes, but none of them are affecting the complaints. People were still complaining at the same rate. So finally, what they did is they rearranged the layout of the airport. They made it so it actually took people longer to walk from their plane to the baggage claim. It took people 7 minutes to walk from the baggage claim, and then it only took them 2 minutes to actually wait on the baggage claim. The number of complaints dropped significantly. People were happy. They didn't feel like they're waiting excessively anymore. So it turns out users hate the perception of load times, not necessarily the load times themselves. What does that mean for us? Pages should be interactable in 1 second or less. And I don't know about you guys, but I've never actually worked on a system where that happens. So you have two options. Improve the page speed, which means you optimize your backend APIs, you reduce your bundle sizes, and a bunch of other techniques you can use, which is not what I'm going to be talking about today. Instead, I'm going to be talking about techniques can be used to trick users into thinking the page loads faster than it actually does. If you can distract the user from the fact that they're waiting, they won't be upset about it. First technique you can use is server-side rendering. I found this wonderful graphic from an article titled Server-Side Rendering with React, Redux, and React Router. And basically the premise of server-side rendering is you render a full view of each route for your client on the server before sending it down to the browser. So as the browser begins to render the page, there's a viewable version of your page with all the content in place. Your front-end framework starts bootstrapping, and once it's finished bootstrapping, the page is now interactable. So what does this get us? The page is perceived to load much faster. Users can begin seeing content as soon as the browser begins rendering and processing the information, even if the page isn't necessarily interactable. It also improves search engine optimization and indexability. It's much easier for web crawlers to index your site if they're just parsing HTML and DOM than it is to run JavaScript. So the downsides of this approach is it's a way more complex architecture. You now have to support both back-end rendering and front-end rendering for every single route in your application. And you may have to make sure you have a way to actually fetch the data quickly for each page on the back-end as well. Good news is this is supported by pretty much any web framework these days. Angular and React, Redux all support it. The next technique we can use is called priority content rendering. It's actually pretty similar to server-side rendering, and the idea is you load and render the main content of the page as quickly as possible, and then secondary content loads and renders afterwards and fills in as it can. This doesn't necessarily mean you have to load all of your main content quickly. For example, if your main content on the page is a table, you can just load the first few rows and then load the rest of them as you can. The user can begin processing the content. This is actually what Facebook does with the timeline. They load the first few items of the timeline, then load the rest of the page in. So to actually achieve this, you have to order all your API calls to make sure to load the most important data first. The advantages of this approach are the page is also perceived to load faster because something shows up quickly. Once again, the user can begin to process the information. The downside is you must tailor the API calls on every page to get the best performance. You have to know which data is the most important to load first and make sure calls are not blocking other calls. Another technique we can use are called content placeholders. If any of you have ever used Facebook, you're probably familiar with this guy. And the idea is you show an animated placeholder component that loosely represents the content that will show once it's rendered. So what do these get us? Well, it signals to the user something interesting will be here. And the animations of the component distract the user from the fact that they are waiting. Animations in general distract users so you can use it to your advantage. If you'll notice, a lot of sites have cute graphics while they're loading. It gets the users focused on the graphic and not the fact that they're actually sitting there waiting. So the advantages of this approach are it's actually a low overhead to implement. These can be styled and created very easily. Just some CSS, and you're good to go. The downside is you now have to have two versions of every component that needs to load data. So you'll have to have a placeholder version and then the actual component that renders the data. The priority content rendering and content placeholders can be combined together for a greater effect. It's what Facebook does. If you'll notice, when the page starts loading, everything is content placeholder, the main timeline, chat, side navigation. They load the timeline in, the first few items, and then they'll load the rest of the data in as they can. Product managers and designers almost never think about loading states. So you as a developer need to be an advocate for them. It's good for you and the company. You want to be the guy who knows what he's doing, and they can always rely on you to deliver excellent customer experiences. All right, let's shift gears a little bit now. Talk about analytics. Let's say you're working at your desk, your boss comes up to you and says, we want to streamline the application. What features aren't used very much? We want to remove those features. You're probably going to say, well, I don't know, boss. That's a really bad situation to be in. Because in that case, you're being reactive. You want to be able to have the ability to be proactive and be the one that goes to your boss and says, XYZ feature is not used very much. Here's the data that's showing us true. We should probably not invest much time into it or get rid of it altogether. So how can we achieve that? Well, it's analytics. So what are analytics? Analytics are tracking user interactions with the application. So every time the user views a page, clicks a button, those are all user interactions. And it allows for analysis of how users use the system. You can track retention, which is how often users are coming to your app, how often users are coming back to your app, how long they're staying on your web page. And it also allows you to determine how often features are used or not used. You can see what your hot features are, where your company should be spending the majority of its time and effort, and which features need to either be replaced or removed altogether. So there's lots of technologies that you can use. At Pluralsight, we use Adobe Analytics and Segment for our tracking. And my advice is track everything. Every single user interaction, every time a user opens a modal, clicks a drop down, you should be tracking it. Because it's very easy to remove events after the fact if you realize you're tracking too much, but it's very difficult to go back and add events later. You've lost the context of all the user interactions and what you're doing when you're in the scope of the code. Tracing. So tracing is logging all the system interactions of your application. It's function calls, errors, API requests, the timings for everything. At the very least, you should be logging every single error that your application throws, because you need to be able to verify that the system is behaving as expected, see how often errors are occurring, what errors are occurring, how severe the errors are, and it allows you to more easily track down bugs. If you have a call stack of all the data flowing through your entire application, you could easily see what went wrong, at what stage it went wrong, and fix it.
What are you using at Pluralsight to log errors?
Segment, and, oh, sorry, Sentry.
Oh, Sentry.
Yes.
Oh, we use that here too.
Do you do any sort of like crash reporting?
No. I mean, back-end crash reporting, yes, front-end, no. Internationalization. So internationalization is enabling content to be translated into multiple languages. So that does not necessarily mean actually implementing the translations themselves. It just means having a framework in place so you can translate stuff if needed. Say you've been working on an application for 2 years. Your boss comes up to you and says, we need to add support for German to the application. How long will it take to add that? If you say to him, well, that will require significant changes. It'll take us 1 to 2 years to support that. Your boss is going to think, this guy's incompetent and doesn't know what he's doing. Why am I even paying him money? Instead, if you're able to say, we have a framework in place to support multiple languages. We just need some personnel to translate all the messages and we can ship it. You can better bet you're going to be getting a promotion. So the internationalization enables the product to move into new markets without rewriting the software. So if your product reaches external customers at all, it should have internationalization. The one caveat to that is if you're building internal-only products, it may not be necessary for it, but your default should always be to think, do I need internationalization? Even if you don't need it right now or next year, you're probably going to need it at some point in the future. Internationalization is already supported by React or Angular. It's built in, and there's some React libraries, React INTL and React IAT Next, which allow you to use it for React. So analytics, tracing, and internationalization are all necessary for enterprise applications. And more importantly, they must be added incrementally as the functionality is built. It's nearly impossible to add these things after the fact. It's a heroic effort to go back through the entire application, add analytics for every user interaction, add internationalization to the entire application. And it's way more expensive for the company, and it never gets prioritized or seen to completion. The company is never going to say, okay, we're going to go through, add analytics to the entire app. We're going to go through and translate the entire app. Or even if they say they are, they start the work and then never actually see it through.
That's awesome. That's true. We've never done that.
So you just got to do it.
At Weave.
And you got to do it as you're building it. Managers and product managers do not understand what it takes to build scalable software. You have to be the evangelist for it, and you have to be the one that does it. You always want to be in control and not reactive to curveballs being thrown at you. So, in conclusion, applications must have a foundation of quality. Every component you build has to be rock solid, or you're not going to be able to ship an application at all. Users need to feel the pages load quickly, but it doesn't necessarily mean they have to. It just needs to mean they aren't thinking the page is loading slowly. Analytics, tracing, and internationalization all add value to the business and need to be added from the get-go. These are all things that are just fundamental to enterprise applications. I know it's not super sexy, but this is the kind of stuff where people will look at you as a person who knows what they're doing, knows how to add value to the customers, and knows how to allow the business to achieve its objectives. Any questions? Yeah.
So you are at a company in a situation where they do need to add some of this stuff after the fact.
Don't ask that question.
Personally, of a previous company that I was at,
There we go.
we added internationalization, and it took like 900 developers. They're still working on it, right?
Yeah, that's my current
Yeah.
company, by the way.
And it's like doing it after the fact is insane. But what do you do if you're coming into a product where obviously they didn't think about it ahead of time? They started building this stuff 10 years ago, and it was only for the US, right? So I guess in that situation, how do you approach it? Like, how do you get someone to prioritize internationalization, knowing that it's probably something that's going to come up when there's a whole bunch of other crap that needs to get done?
You get lawyers involved.
So what you've got to do, first of all, is set expectations. You've got to communicate clearly that this is the scope of what's actually going to be required to achieve these. And if the company values it, we're going to have to spend some time and effort on it. And then it just comes down to, as you're touching areas of the code, you got to start slowly adding it. Like I said, they never actually sit down and say, okay, we're going to sit and translate this page or whatever. So you're just going to have to take it upon yourself, build it into the tech that you're addressing, and just do it incrementally as you can.
Is that how it was done at Pluralsight, or did they build internationalization from the beginning?
Also, that's kind of worms. We currently don't internationalize at all, and it's something that's going to be affecting us very soon. So.
Yeah, okay, cool.
Yeah.
So you talked a lot about quality, right? And making sure that you have top level quality all the time because that compounds. I imagine that has to be driven from like the engineering culture. What do you guys do at Pluralsight to build that culture of high quality?
Yeah, so a few things we do is, the most important thing is tests are non-negotiable. You just don't get the option to not write tests. Everything you write has tests. It's obviously the hardest one to achieve because usually there's a very non-testing culture at most companies. But if you can achieve that, that's going to be your solid foundation. The other thing we do is two pairs of eyes required on every piece of code that gets committed. We do a ton of pair programming at Pluralsight. Almost every team pair programs. That helps a lot. You get the context, two people in the context, see problems other people can't see. Those three things are going to get you the most bang for your buck for achieving quality.
Cool. With the pair programming, do you ever have the scenario, the problem where the pair are just doing pull requests back and forth with each other, and so you're not really getting additional eyes on it? You're just bouncing it back and forth. Or
also, when we say pair programming, is there's literally two people sitting coding together at a point in time. If they're doing pull requests, it's not pair programming.
okay.
Does that help answer your question? Or?
I just in pair programming, I've seen it where they bounce back and forth and they don't actually include a third person to see the pull request.
Oh, you said they don't get
The
extra
other person's
eyes.
just approving the other person that they're watching.
I think that's just programming.
So
No, he's saying they're pair programming, and then they submit the pull request, and then the person, one of the people that was doing the pair programming is approving the pull request.
Also, at Pluralsight, if two people are pairing on the code, you can just commit it straight to master.
Oh, yeah, okay. So that's what I'm saying, is if you have two people on it, that's fine.
You just go straight to master. Okay.
And it is a little bit of a challenge to keep both people engaged most of the time, but it actually works pretty well in practice if you have a culture of it.
Health checks. What kind of software are you using, or kind of apps for the health? Yeah.
So we just use AWS. We use a lot of their built-in stuff. Most teams just hard code their health check endpoints, so we don't have a standard way of doing it across the entire company. And then we use all the AWS goodies, scaling.
So are you like on microservice? Are you in containers like Kubernetes or anything like that?
So teams at Pluralsight are very autonomous. They choose their own tech stack. They choose what they are. Some teams are on Kubernetes containers, some are not. You could call them microservices. We call them bounded contexts. In practice, they're just bigger or smaller monoliths. But the idea is that each team can understand the entire scope of their code base easily and be able to make changes on it. And then each team deploys their own code and integrates with other teams.
So you're talking about testing. Do you do any like visual testing or like user interaction testing?
We don't. I think it's valuable. The problem in general you face with UI testing is it's very brittle.
Yeah.
But what you kind of can aim for with UI testing is try to get your core user workflows, have those under UI test. Those are most likely not going to change frequently. They're kind of the foundational ones. And they can give you
Some
most of the bang for without too much of the downsides. All right, thank you.
Yep.